The reason that we look at these cases separately is that when you do two variable systems, you sort of establish how it works. You understand what the techniques are. You generally kind of get an understanding for dependent, independent, inconsistent systems. The reason we look at three variable systems is because it's the principle applies to everything else. Now that we know the techniques, the techniques that we're going to use now would apply to 4 variable, 5 variable, but you'd have to be nuts to try and do anything more than about 4 variables using these methods. Wasn't the case years ago. I mean, now you got software that'll do it for you, and later on you'll have a MathCAD assignment that'll solve 10 variable systems in the click of a mouse, whereas you could go crazy trying to do that. You can't graph 3 variable systems. Because why? You need another dimension. Right, you can graph x and y because you've got an x-axis and a y-axis. If we wanted to graph 3 variable systems, x, y, and z, we'd have to have a z-axis. We'd have to be able to graph in 3 space. That's a little tricky. So, we really only have 3 techniques. We're still going to have the substitution method. We're still going to have the elimination. Then we're going to use something called Cramer's rule. We're going to do that tomorrow. But today we're going to look at elimination and substitution. So, 2 very short objectives for this time. We want to solve 3 variable systems using substitution, and we want to solve them using elimination. We're going to jump straight into an example because we've already established all the tools that we need. We're going to do this one by substitution. Did I click that to the next screen, or did you, Aaron? I don't remember moving to this screen. Oh, well. Well, let's use substitution. You use the same idea that you used yesterday. You want to choose one equation and one variable that's easy to solve for. Now, as you kind of peruse those choices up there, would you rather solve the top, middle, or bottom equation for x, y, or z? Top one for x. Why not? Top one for x, y, or z would all be good answers, but let's solve the top one for x. So if we do that, I won't show the algebra here, but I think you'll agree that x is equal to 35 minus y minus z. Everybody agree? Now we're going to substitute that value of x into the other 2 equations. Then this equation becomes 5 times, let's go down here, let's go over here. We're going to have 5 times x, but x is 35 minus y minus z plus 4y plus 3z equals 22. It's the same principle. Yep, you're substituting one function in for another. Okay, and the bottom equation is going to become 3 times, not x anymore, instead it's 35 minus y minus z. Plus 4y minus 3z equals 2. Yep, you do. Because what did we just do? Now that we've made substitutions into both of the other equations, what have we really accomplished? You what? Yeah, right. X is no longer a player. Now we have 2 equations and how many variables? 2. Every time you do a substitution, you reduce the number of equations and the number of variables by 1. So instead of a 3-variable 3-equation system, we end up with a 2-variable 2-equation system. Now we simplify that, and we solve that system. So, if we simplify these, the top one, this one right up here, this is going to become, good. These will become, the top one up there becomes 175 minus 5y minus 5z plus 4y plus 3z equals 22. Well, we can rewrite that a little bit and say that this is, put the y and z's together, put the constants over here. Let's count the y's. We got negative 5y plus 4y. We have negative y minus 5z plus 3z. That's minus 2z equals 22 minus 175, negative 153. So this equation right here, when you distribute and combine, becomes that. Everybody follow that? Okay, what about the bottom one? The bottom one right here is going to be 3 times 35. That's 105. Minus 3y minus 3z plus 4y minus 3z equals 2. Combine there in the same order. We've got negative 3y plus 4y is y minus 6z. 2 minus 105 is negative 103. Okay, so here's our two-variable system. All right. Well, that's not bad. Everybody okay with this part up here? I want to save the original system, but I'm going to erase this part of it now to gain a little bit of room. Okay. So our system now is negative y minus 2z equals negative 153. And y minus 6z. Oh, that works out beautiful, doesn't it? Minus 103. Okay, well, the method of solving here should be pretty clear. Let's add those two equations together, and what do we have happen? The y's are gone. Negative 2z minus 6z is minus 8z. Negative 8z equals negative 153 minus 103 is negative 256. And so z equals 32. All right. Z equals 32. Now, once we get z, we got to start working backwards. Now we can find y. Everybody okay with z being 32? Now we start working our way back to the beginning. We're going to go back to any equation, that one, this one, any of them that involve x and y, and we find y. So negative y minus 2 times 32 equals negative 153. Add 64 to both sides, we get negative 89. So y equals 89. We have z, we have y. We don't need this anymore. Now we can go back and choose any one of those equations to solve for x. We had solved for x at one time. You could use that. I wish it was still here. But we know what x and z are, and that's a pretty simple equation to solve. So we can grab that top one. X plus y, which we know to be 89, plus z, which we know to be 32, equals 35. And if you solve that, x will turn out to be negative 86. And we solved the system. Now those are also given in ordered triples instead of ordered pair, ordered triples often. So we would say that the solution here is negative 86, 89, 32. And we're done. Now it's worth noting that the two problems that I have here are already arranged in nice XYZ columns. Beware that in your homework today they're not, and so you will need to rewrite them. We'll look when we're done with this just at one that's mixed up, and we'll just look at rearranging, but this one's already done for us. Okay. Well, we're going to eliminate. We have to make two decisions. One, which equation we're going to sacrifice, because we're going to, just as we made two equations into one before, now we're going to make three into two by elimination. So we're going to give up one of these equations, we're going to sacrifice it in order to cut the other two down to two variables, and we have to decide which variable we want to eliminate. Now, this one will be an easy one to eliminate x with, because it's so easy to multiply this by negative 3 to eliminate x with this one, and you can multiply it by negative 5 to eliminate x with this one. So we're going to use this equation, use the bottom equation, to eliminate x. So let's start with the top one. What do I multiply the bottom equation every term by in order to make x disappears with the top one? By negative 5. If I multiply this by negative 5, I'll have negative 5x that'll be gone. Gabe? Right. It's similar to the last example in that we're still going to take a three-variable system with three equations and reduce it to 2 and 2. So we still have to do that. So let's multiply this bottom equation by negative 5. I'm going to multiply this equation by negative 5, and this becomes negative 5x plus 15y minus 40z equals negative 27 times negative 5 is 135. So what do we get up here? What do those two now yield? X's are gone. 16y minus 44z equals 130. There's one equation in two variables. We're going to get another one when we do the same trick to this bottom equation. Except here we're going to multiply it by what? We're going to multiply it by negative 3. So we get negative 3x plus 9y minus 24z negative 27 times negative 3 is 81. And we can combine those two. X's are gone. Negative 5 plus 9y is 4y minus 30z equals 61. Okay, so now we've got two equations in y and z. What's this equation good for now? Nothing. Okay, we used it. We fused it into those other two equations, and now it's gone. Stop there for a minute. Everybody agree with that? Look okay? All right, this one's history. So now the equation that we have to solve is 16y minus 44z equals 130 and 4y minus 30z equals 61. And we would solve this system. All right? Now, what do you want to do to solve this system up here? 16y minus 44z equals 130. 4y minus 30z equals 61. How do you want to solve that? Use elimination and eliminate y's. Multiply this equation by negative 4. I'm going to tell you what the solutions for y and z are. You should be pretty skilled at solving a two-variable system right now. So I'll tell you right now that when you solve this, y will turn out to be 4. And z will turn out to be negative 3/2. Okay, so you solve this system and you get solutions for y and z. And what's your final step? We have to go all the way back to one of the original equations and now find x. We can say that again? Yep, exactly. They're all still true. Drew? So now we'll go back. We'll choose, let's grab that bottom one, the bottom equation of our original system, since it's got x already isolated, and we can find x. X is equal to, x minus 3y, x minus 3 times 4. The bottom equation, plus 8 times negative 3/2 equals negative 27. And x turns out to be negative 3. And so if we write that as an ordered triple, the solution to the system is negative 3, 4, negative 3/2. And we're done. So we eliminated. All right. We're about out of time, but I want to make one more point before we wrap it up. We're not going to solve this. We obviously don't have time. But look at those equations. It's kind of patchwork. Let's look at the top equation, for example. 3x minus 5y equals negative 22. We need to write that so that the x, y, and z columns are all aligned. How many z terms have we got there in the top equation? There's none. In the top equation, there's none. And so that would become 3x minus 5y and plus 0z, there's no z's, equals negative 22. Negative 22. What? Exactly. We just need to make it a placeholder. The second equation will become negative 3x. How many y terms in the second one? Move the 8z to the other side, minus 8z equals, and what's our constant in the middle one? Third equation, x minus 3y plus 6z equals negative 1. And now it looks like the other ones, you could use any technique you want.